Hey, and welcome to my channel, Fun with Revit and Dynamo. In today's video, we will explore nested families, and we will demonstrate it by creating a parametric welding plate, like the one shown here. But what is a nested family? It's quite simple. It's just a family inside another family. Instead of loading a family into a project, you load it into another family. So when to use nested families? Nested families is very nice to use when the family has repeated components, like our vending plates with these bolts. So here we have 4 bolts that we're gonna create a nested family that loads into the main family, that will be the welding plate. Other advantages by using a nested family is you can place a combined geometry and a rather complex setup as one single unit, where you want to control it as a whole in relation to other elements, and in general keep the family you load the nested family into cleaner and less chaotic with less reference planes. But never nest more than once, because if you go back more than one nest, it will slow down the project quite significantly. For instance, we will create one nest in this family. We create the bolt as a family and load it into the welding plate family. That's just one nest. But if we double nest, we had another family here that we loaded into the bolt family and then loaded the bolt family into the welding plate family. That's a double nest. We want to avoid it to keep the family lighter and easier to operate in the main project. We will start by creating our welding plate. We create a new family. This will be metric generic model phase based, because our welding plate will be cast in concrete. To create the family, we follow our 4-step process outlined in previous videos. We start with the skeleton, that is our reference planes. We then add the muscles, annotations, dimensions. Next up, step 3 is the brain. We create the parameters that we link to our muscle, the dimensions and annotation. And lastly, we add the geometry, the skin of the model. But let's start with the reference planes. We will create the welding plate here. This will be the width and length. We cross off the equal because we want this to be evenly across the center line, equal parameters. This will be our length. We do the same for our width. We go into the front view. We're setting up our thickness. We want it below the surface because it will be cast inside the concrete. And we have set up both the reference planes and the dimensions. Let's go on to parameters. We create all the parameters. This will be length and dimensions. So we want to separate all our plate parameters and bolt parameters. So we will name all our plate parameters with plate in it, and all our bolt parameters will have bolt in the name. We also want to add the materials. This will not be length, this will be material, and grouped under material and finishes. Apply. We have set up now our parameters. We now want to connect our parameters to the dimension lines. So this, we just press the dimension line, and up here you see the label. We can choose between our parameters that we have created. This will be the length. This will be width. We go to front view and add plate thickness. Plate thickness, we change it to 20. We change the scale to accommodate this. So we are finished with the brain and connected the brain to the muscles and the skeleton. Now last step is the skin. That's our geometry. We will do this by an extrusion. Just plant it out. I like to align the extrusion to the reference plane and not place it like on top of it, because I feel like I have a little more control when I do it, but that's just my preference. Use the align tool to align and lock to lock our geometry to the reference planes. Press accept. We go to the front view. We want it to go below the surface. We align it again, lock it. We go into the 3D view and we make this a void so we can easily see the plate. Now we go for some flexing. We check if we have set up the plate correctly to see if the plate changed when we change our parameters. We also want to connect the material. So we pick the plate and go over to properties, under material and finishes. We need to associate this material tag to our parameter we created, like that. And that's conclude our welding plate. Now we want to create the bolts, but not in this family. We wanted to create it in another family. So we go to file with new family. This will just be a metric generic model. So the parameters for our bolts will be bolt diameter and bolt length. Go on to front view. We create our reference planes. So what is it we actually is creating here? If you take a look at our bolt, we have this bolt and then we have some kind of expansion at the end. The total parameter is the length, and then we have the length of the bolt before the expansion, and then we have the length of the expansion and the diameter. We are setting up the parameters for our bolt. We name it bolt to separate it from our plate parameters. Also here we make it type. Alright, bolt diameter, bolt length. We will also want both material, that is material, under material and finishes. And we also want the bolt head diameter, the expansion, so the diameter of the expansion. This will not be a parameter that the user can change. It will be a fixed value, so I place it in other. We also want bolt head length, also other value. User will not change this one. This will be the total length of the bolt, just the bolt length. We can change this one. This will be the fixed length, bolt head length. I will set this to 30. I change the dimension. So if you change this one, the other one will follow, and this one is fixed. We can make this fixed by entering the bolt head length as 30. So it will always be 30. We now enter the reference planes to create our bolt. So first one is the clean bolt with the same geometry. It will be in an extrusion, centered in the center. We add the dimension. This will be the bolt diameter. Change the bolt diameter to something more realistic. Change the scale. One more time. Nice. We go to the front view, from front view, we go to this front view. We see our bolt. We align it to the top and to the bottom. This will not go all the way to the bottom, for here we have our expansion, and we would like to create a new geometry for that. We again go, let's test it, let's flex it first to see if it works. Yeah, that works. Next up, we want to create the end of our bolt, or expansion of our bolt, as you can see here. We do that by creating a blend. A blend is something that changes size along its length with two different profiles. So what we want the first profile here that will be the same as our bolt clean diameters, and then we want the second profile here that is a larger diameter than the first one. So we go to create, blend, work plane first. So we pick this one. We go to floor plan, create our blend, same diameter. We edit the base, we create a new diameter that is the end. We associate, we create a parameter and connected to the bolt head diameter. Press OK. We go to the front view to check our blend, something like that. We then align it to the reference planes, connected to the bottom, to the top. We now have our end. Let's see if it works. We change our diameter to 30. So you can see top profile didn't expand. So we go to ref planes again. We edit the top, base. So the base need to be the same as the top. We add a parameter. We connect the parameter with the bolt diameter. We accept. We go again to the front view. Yes, now it works. But the end, we want to create a formula for our parameter end. So now it's fixed at 50, but we want to create bolt multiplied with 1.7. Actually 1.9, as you can see. Now again, let's test it. Bolt diameter. So when we increase this bolt diameter, the blend will also follow because of our parameters. If this is 50, this will increase. Let's go back to 25. This will sync. We try to expand it, and it works. So we have created our bolt, and it works. So now it's time to load it into our welding plate family. We can let's save it as a family. So we don't want to load it into our project, but we want to load it into our family. And we place it out. We go to front view to see, yes, this is our bolt. So the great thing now, we have a repeating components. That is a nested family without all the reference planes that we would have created in this family. It would be a total mess. But luckily, we made a nested family. So we want to place it on our welding plate with a distance from the edge that the user can change. So we are setting up new reference planes. We add dimensions. We create our parameters. We just call it E1 and E2. These two will have the same E1 parameter. So if we change this one, the other one will also change with it. We associate this with E2. And then we just copy this. And then the aligning part starts to align this line with the center, lock it, center, lock it. We see if this works by flexing. As you can see, our bolts is following our reference planes that we changed. So it works. As of now, the end user do not have access to the bolt parameters if we load it into the project. So we need to connect the parameters from the nested bolt family to the host family, so it will be accessible for the end user in the project. This is a bit complicated with nested families, and it's easy to get it wrong. I will show you how it works. So first we create the same parameters inside the host family that we want the end user to access from the bolt family. So what do we want? We want bolt material. This is material. Okay. Bolt length and bolt diameter. We push them down and assign them some values. And now we connect them to the bolt. So let's press one of the bolts. We go to edit type and we associate the bolt diameter that's in the bolt family. Connect them with associate family parameters to the newly created bolt diameters in the host family. We do the same with length and bolt material. The last task is to align the bolts in the set dimension. We go to the front view and start aligning our bolts to the bottom of the thickness of the plate, this reference planes. Press align. We do it for all our 4 bolts. Like that. And we go to the 3D view and check. Looks pretty good. We load it into our project and place it on our concrete floor. We make this a little bit more transparent so we can see our welding plate, and let's take it for a spin. We change all the parameters to see if it works. Everything works perfect. This concludes our tutorial on nested families. Thank you for watching. Please like and subscribe.